Hello. Yes, we welcome you to PSSB, Physical Sciences Celebrate with me, Richard here. So this question comes, it says that consider the salts below. So the salts are ammonium chloride, sodium oxalate, sodium chloride, potassium chloride, sodium ethanoate. And then the question says that identify which of the salt above is not hydrolyzed. Explain and state the resultant pH. So we have all these salts above, but which one is not hydrolyzed? Okay, the answer is sodium chloride. So it is sodium chloride. Okay. Yes, sodium chloride does not undergo hydrolysis. Okay, why? Okay, the reason is that when you look at sodium chloride, it is NaCl. So when you look at its constituent ions, you have this one as sodium ion, and you have this one as chloride ions. If you trace the origin of these ions, sodium ions came from sodium hydroxide, and chloride ions came from hydrochloric acid. Now you need to know that sodium hydroxide is a strong base. Okay? And hydrochloric acid is a strong acid. So now you need to know that ions from a strong base, okay, like our sodium chloride, and strong acid like chloride ions, they do not undergo hydrolysis. So that's the reason. What's the reason? The reason is that sodium chloride is produced from a strong base and strong acid. Okay, then you say ions from strong acids and strong bases, they do not undergo hydrolysis. Okay, that is that. Yeah. Then comes this question. It says that write the equation for the hydrolysis of each of the salt above and state the resultant pH. When you come to pH, I need to remind you that we realized in the previous question that the salt sodium chloride does not undergo hydrolysis because it's made from strong acid and a strong base. So what is the resultant pH of such a mixture of such solution? The pH is neutral, or pH is equal to 7. So then we come to this question. We are writing the equation for the hydrolysis of any of these, and we are stating the pH. Okay? The first one, we are having ammonium chloride. Okay? So hydrolysis is handled stepwise. The first step here is to separate this compound into its ions. So here we are having ammonium ion here and the chloride ion here. Okay. So ammonium ion comes from what? It comes from ammonium hydroxide. And the chloride ion comes from what? It comes from hydrochloric acid. Okay. So from there, you need also to identify that ammonium hydroxide or ammonia is a weak base. And we need also to realize that hydrochloric acid is a strong acid. Okay. So if that's the case, what do we do? You need to know that ions from strong acid or strong base are not ionized. So for this case, what do we say? We are saying that chloride ions, because they are from a strong acid, they don't undergo hydrolysis. That leaves us with only one ion, which is ammonium ion. And it's the ammonium ion which is going to undergo reaction with water. Okay. Giving you what? So we need to know that ammonium ion is proton rich. It has a proton. So the presence of a proton here makes it acidic. So it becomes a proton donor, donating a proton to the water. So what happens is that water gains a proton to become hydronium ion. And when ammonium ion loses a proton, it becomes ammonia. Okay? So the question now comes about the resultant pH. Where do we see to trace the resultant pH? You look at the side of the products. And when you have hydronium ion in place, it determines the pH. So the pH is going to be pH is going to be less than 7, medium acidic. So that is it for ammonium chloride. Next is sodium oxalate, which is, I prefer using structure formula for this one. It imparts more meaning than the one they use. So what happens here is that you break this one into its constituted ions. So you have the oxalate ions and sodium ions. Next, you trace the origin of these ions. Oxalate ion came from oxalic acid. Okay. And sodium ions came from sodium hydroxide. Now the question comes, oxalic acid, is it weak or strong acid? It's a weak acid. And sodium hydroxide, is it weak or strong base? It's a strong base. Okay? So with that, what do we do? You have to take note that ions from a strong acid or strong base are not hydrolyzed. So that gives us oxalic acid as the only ion to react with the water. So what do we have? We have oxalate ion plus water. Now you need also to know some stuff. When a compound is like this, it's normally proton seeking. It's negative and the proton is positive. So it's normally proton seeking and the chances of it taking up a proton is very high. So because it's going to take up the proton is the base and the water is the acid. So water donates a proton here, but you have to know that it donates a proton to both this negative charge. We'll deal with that one during balancing. But this one, after losing a proton, what remains behind is OH. So now we have the task of balancing. So when you look at this scenario, what do you notice? You notice that here we have 3 2H and 3H. So you can put here to make it even 4H. Then how do you make this one 4? By putting a 2 here. So the equation is balanced. But now we have to come to the issue of pH. The moment you have hydroxide ion here, it means that your pH is greater than 7, meaning the medium is basic or alkaline. Okay. So next is sodium chloride, but we dealt with that one already. It doesn't undergo hydrolysis. pH is neutral. Then we come to potassium sulfide. Okay. The formula for potassium sulfide is K2S. Okay. What is next? You find its constituent ions. So you break this one up to give you potassium ions and sulfide ions. Then you trace the origin of these ions. Potassium emanated from potassium hydroxide and sulfide came from hydrogen sulfide. Okay. Then next step is to find out whether potassium hydroxide is strong or weak. It's a strong base. Okay. Then you come to hydrogen sulfide. Is it strong or weak? It's a weak acid. Okay. Then you need to remember that ions from strong base or strong acids are not hydrolyzed. So that leaves us with only sulfide ion, which is going to undergo hydrolysis. We are having sulfide ion reacting with water to give you, like I said before, when you have a negative here, it means proton seeking. So the chances are that it will take up a proton. So what happens here is that this water is donating a proton here. Okay. So when the sulfide ion gets a proton, it becomes H2S. The 2 will be dealt with during balancing, but just know that it took up a proton. But when you're writing the formula, write it correctly, because sulfur is valence 2 because it's a group 6 atom, and hydrogen is valence 1. So through exchange of the valences, this is the formula of the compound you get. So next, what is the next one? Next one is going to be when water donates a proton to sulfide ion, what remains behind? What remains behind is OH minus. Okay. Then the issue of pH comes in. Whenever, let us first balance the reaction. Yes, we have two hydrogen, of one sulfur. Yes, these hydrogens are 3. So you put a 2 here to balance that. Now there are 4. And you put a 2 here to balance that. Now it's balanced. Now back to the pH determination. The moment you have OH, what do you predict? Yeah, pH is greater than 7. Medium is basic. Yeah. Then lastly, we have sodium ethanoate, which is CHCOON. Okay, that's the salt. What do we do? You break it up into its constituent ions. Here you have ethanoate ion, and here you have sodium ion. Next, you trace the origin of these ions. You have to know that ethanoate ion comes from ethanoic acid. Okay, and sodium ions come from sodium hydroxide. Okay, so from here, what do we do? You have to remember that this one, which is ethanoic acid, is a weak acid. Okay, and this one is a strong base. Then you proceed and say that ions from a strong acid or strong base is not hydrolyzed. That leaves us with the ethanoate ion as the only ion to react with the water. So it reacts with the water and in the reaction you have to know that I told you the moment you see negative is proton seeking. So it's the one which is going to take up a proton. That makes water to be the proton donor. So when water donates a proton to ethanoate ion, what do we get? We get ethanoic acid. Okay. And after loss of a proton, water becomes what? It becomes OH minus. Okay. Then the equation is balanced. What is next is prediction of pH. The moment you have OH, it means that the pH is greater than 7. Medium is basic or alkaline. And with that, I would like to thank you for your time. The channel is PSSB Physical Sciences. Silver Bullet, we urge you to subscribe, to comment, to like, to share. And we remind you that Physical Sciences Silver Bullet is a YouTube science channel handling physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We recommend that when you go to our channel, use playlist. Don't go to video. Go to playlist and select material which belongs to your level. For grade 8, pick or click Natural Sciences grade 8 or Natural Sciences grade 9. For grade 11 and 10, pick or click Physical Sciences grade 11 or Physical Sciences grade 10. For grade 12, we urge you to, for grade 12, each chapter is presented independently. So just go to the chapter of your choice and click it to have all the material which you need for that chapter. With that, I would like to say thank you. Stay blessed. See you next time. Bye-bye.